We're working on the block diagrams. So when we have this kind of really sophisticated whole system, we can separate them into small boxes and we can combine them later. So last time we looked at all of this. So we have the signals representing as arrows. Okay. And we have a box as a system. This is the transfer functions, input and output. We have a summing junctions, and we could have the negative, positive. We need to show that positive or negative right next to the arrowheads, and then pick off points. And then we look at the cascade form last time. Cascade form, you just need to multiply them all. So when we combine these three boxes together, all those transfer functions, you just need to multiply them, and that is the one box. And when we have a parallel, and they share the starting nodes and the end nodes, that means they are parallel, and depends on input signs to the summing junctions. We can have add or subtract, put them all together, so we can put it into one box. And we look at the feedback form and derive the feedback form. So we'll find the expression for E of S first. And E of S is all of S minus H of S times C of S. And we said we're going to deal with only minus for this class. And then we're going to look at the C of S. C of S equals the E of S times G of S. Now we're going to solve for this guy into E of S so that I can let them equal to each other. And when I do and sort it out, so our objective is to get the C of S together and then G of S together. So the C of S over R of S is this. We have C of S over R of S also in this term. So we're going to move that to left-hand side and let them equal to G of S. And then we're going to factor out C of S over R of S. We solve for that. So that will give us G of S over 1 plus H of S times G of S. So that's combining feedback form. I ask you to copy this down, and it's going to be a really important one. We're going to use this over and over again. So when we combine this numerator at the top, G of S over 1 plus, which since we have a minus here, G of S over 1 plus G of S times H of S. Briefly, we talked about open loop and closed loop. This is the open loop transfer function, and that equals G of S times H of S. However, the closed loop transfer function is G of S over 1 plus G of S and H of S. That's what we had when we combined these two. And then moving blocks from here, some reason, we're going to look at the examples. Some reason we want to move the G of S before the summing junctions. And I said you need to follow these arrows. If you look at the X of S is supposed to take the G of S. However, if we move this guy to before summing junction, X of S is not getting G of S. That's why we need to multiply G of S here as well. And if you find the expression for those, it makes sense. This plus this plus that, we end up getting the same one. Now, if you want to move G of S to the after the summing junction, now this time this X of S is not supposed to get this G of S. That's why we need to divide G of S so that X of S is not going to get G of S after this passing G of S. And then when we look at the expression, and then they are the same one. For a pick off point, if you want to bring this back, obviously we need to divide those G of S, and then we need to bring this side, we need to bring everybody. So let's work on this. Now, first thing we want to do in here, we can do combining G of 2 and G of 3. These are the cascade one. And these H1, H2, H3, they are getting into the summing junctions. and they are all parallel. So first, we're gonna combine all of these, and then we're gonna combine these cascade, and then we'll go from there. So if you combine these three, h of 1, h of 2, h of 3, and that'll give us what? H1 getting into negative terminal. So we're going to use H1, and then H2 is a positive. We need to change it to the negative. H3 is a negative. We're going to keep it at positive because getting into this summing junction, we use negative sign right there. So that's how we combine all those parallel terms. We need to look at the sign. In the original sign is negative, positive, negative, right? H1 is negative, H2 is positive, H3 is negative. And the final feedback, we have a negative. So all the negative input is going to be positive. Positive input should be negative. So the question is, why I pick this as a negative? Because we said we're going to consider feedback as only negative so that we can keep this as a positive when we combine them. Minus, right? If this is plus, then this guy is going to be minus. But as I said, feedback term, we're going to use negative sign only in this class. And then we are going to combine these two. So that's what happened in here, G of G3 times G2. And once we have here, now we have a choice. We can do combining this feedback, or I can move this guy to this side. So if I move this to this side, and I'll do both, but just let you know that if you decide to move this guy to here so that I can combine this and this together, this guy for the feedback is not supposed to get this. That's why we need to divide G1 of S if you decide to move G1 to the right side of the summing junction. Make sense? And then we combine these two. So when we combine these two, we have this. So try that. And that 1 plus, we need to have a common denominator, and you need to work on it. So this is the final answer. That's one way to do it. And if we decide to go combining these two together first, before I move this guy, then combining these two, we end up getting this. Now, we don't need this summing junction anymore. There's no coming in this side. So simply you can ignore this, and then these two cascade, just multiply. We end up getting the same answer. This is the problem 5.8 prime, so I modified a little bit. So if you know how to do this, you should be able to do one of the homework problem, which is 5.8. So this is the your second page of your handout. So now reduce this whole boxes into one transfer function. Let's do this first. These two are parallel, not the feedback. So what's the main difference between the parallel and feedback? You need to follow the arrows. This is the parallel going into this summing junction, same direction. So it's a parallel. If we had the opposite way getting into summing junction, then it's a feedback. So when we combine these two, we just need to add them up, right? And then these two is a feedback. So I want you to add these two. And for this guy, for the feedback, T of S equals G of S over 1 plus G of S times H of S, right? And this feedback, watch here, there's no H of S, and it's just a line. It's what we call unity feedback. If you don't see any boxes like H of S, this value is going to be 1, constant 1. So if I apply this guy here, G of S is what? 1 over S. 1 plus G of S is what? 1 over S times H of S is going to be 1. And for the parallel, you just need to add them together. 1 over S plus S plus 1. Now it's just algebra. You don't want to carry this. Why are you simplifying all of this? It's going to be really messy. So every time you have something like this, like a fraction inside of the fraction, make sure you combine them. Same thing for combining 1 over S plus 1. Don't keep it like this. At the end, it's going to be really messy. So that have a common denominator as 1 plus S squared plus S. For this one, we have 1 over S 1 plus 1 over s, and then I want to have a common denominator. So s plus 1 over s, 1 over s, that is 1 over s times s over s plus 1. We cancel 1 over s plus 1. So as you go on, combining all these boxes, make sure you have the single term. So for parallel, we have that. And then this feedback, we have 1 over s plus 1. So now we have this. That's the feedback, right? So we need to apply this guy. Do it. So this time g of s is this. This is the main one. This is the feedback one. So g of s is this over 1 plus g of s times h of s. So here's what I did. This is g of s over 1 plus g of s times h of s. So I can cancel s and s. Or what I did, I look at the numerator, it is something over s. So if I have denominator something over s, we can easily cancel that out. So I keep this s and then have a common denominator. That means we have a s plus s cubed plus s squared plus s over s. Now we have the numerator something over s and the denominator something over s. The s cancel out. So that is our final expression after we combine these two. I mean, it's just simple algebra. I mean, if you want to cancel this out, we end up getting the same answer. G of s is the main flow. We are going from R of s, input to output, right? G of s is that direction. And then feedback is always going to backward. So we combine them, we have that. So now we cannot apply this feedback because we have two terms here. So these two terms called cascade, simply multiply them together and the feedback. So cascade, you just need to multiply them. And then that's what we have. This is feedback. You need to apply T of s as G of s is the numerator. 1 plus G of s, numerator, times H of s, which is 1 this time, because it's a unity feedback. Do it. So s to the 4th plus 2s cubed plus 4s squared plus 3s plus 1. That should be the result of combining these two. So that's the final answer. Drop your pencil. Watch here. So this guy, what we did here, we're combining these two, unity feedback, right? 1 over s with the unity feedback. Here is a little trick. When we have unity feedback, 1 over s and unity feedback. Combining unity feedback for the g of s, take the numerator, add to denominator, right? And this guy, here's a unity feedback. Take the numerator and add to denominator. So you don't have to actually multiply these two for the unity feedback. Write that down. Write it down. For the unity feedback, always, if it's a unity feedback, you take the numerator and add to the denominator. Numerator is the same, and the denominator, we're going to add the numerator to denominator to get unity feedback form. So we don't have to actually calculate this g of s over 1 plus g of s h of s if we have a unity feedback. If we have a unity feedback, hey, this is unity feedback. I just need to take the numerator and add to denominator and get rid of this unity feedback. That's our new T of S. Next, this is a little bit more. So by looking at this, what do we do? I mean, any suggestion? Great. That's the feedback. So we can combine those two. So here's another thing. I want you to write this also down in your note. For chapter 5, we are not moving lines. We are moving boxes. Don't ever try to move any lines. I'm not moving lines from here to here. I'm moving the box G of 2 from here to the left side. Why? If I move this box to the left side, as you can see, these two are parallel so that we can combine them. But at this point, when this is not parallel because of this G2, I'm going to repeat that again. We are moving boxes. Write that down. We need to move boxes, not the lines. So combining these two, and in order to take care of this parallel one, I'm going to move this G2 to the left side of that. And you see this parallel, unit parallel into this summing junction is nothing. This is not supposed to get G2. But after we move this to the left, this line will get G2. That's why we need to divide. Once we get to here, now 1 over G2 plus 1. That way we can combine the 1 over G2S plus 1. This is something I want you to do in the handout as well. Dotted line, circle it, and put the new expression and say they are parallel. And then before we do that, make sure you say move this box to the left side. And then we already combine feedback G3 over 1 plus G3 times H of 3. Now we can do the feedback here. So that's G2 of S over 1 plus G2 of S times H of S. Why these two are not parallel? So these two are parallel because the endpoint, they're all getting into summing junction and there's no lines in between. So clearly, nothing but these two boxes, starting point and end point. We okay? That's the parallel. But if you look at right here, there's a feedback, so it's not clear cut. And starting point is okay, but end point is not because there's a line. Before this guy getting into summing junction, this guy is fitting back into there. So from here, what did we do? Cascade G1, we multiply to second block. So we have that. Now we're done, right? So these two are feedback, these two cascade, and you can simplify that. Okay, so we got that. And now we have parallel, you put them together and cascade. So this is the final answer.